Well, hello again, everybody. So I have all of our information up here. I kind of zoomed the window a little bit. I'm hoping that'll make it a bit easier for me to draw when we're doing this, and make it a little bit easier to do the text and whatnot. So we'll kind of pick up now with the SR Latch NAND version. That's going to be very similar. I've labeled this one S prime and R prime. You'll notice I flipped which one it is, but I've kept the Q's the same. That's because this is going to kind of function like set did, and this is like reset did, but they're going to be actually the exact opposite. So this will be the negation of set, and this will be the negation of reset. So if we want to have it hold, we're going to have to do 1, 1 instead of 0, 0. And that's kind of, I'm stealing from over here a bit, but you've already seen the pen cast, so um, that's basically what's happening. But we'll walk through why we're going on. So let's start off here. Um, I've got set prime as 1 and reset prime as 0. At least it's easier to draw. Okay, so um, with the NAND gates, let's consider this bottom one here for a sec, right? A 0 on the AND part of it guarantees that the output of the AND will be a 0. Negated will give me a 1. So if I see a 0 here, it'll force a 1. Whereas a 1 going into the AND part of the gate, I need to know the other value. It'll let whatever that value is through, and then that'll get negated. So this one is still kind of indeterminate. It's based on whatever this value is. This one, it is irrelevant what Q prime is. That 0 will force it through, and we are guaranteed to get a 1. Um, Now, I have two ones on the input here. The AND will give me a 1, negated will give me a 0. So that means Q becomes, oops, Q becomes a 0 and Q prime becomes a 1. And the meaning of this is that we have just done a reset. I kept the old value here, um, or sorry, the first one I kept the old value here, and this one updated. And